Stanford University.
All right, welcome to Lecture 6 of CS193P. Today we're going to talk about how to really architect an iPhone application. We'll get a little more into detail on Model View Controller, which we touched upon last week. And we'll talk about view controllers, which is a basic building block that you'll become very familiar with over the next few months. First, any questions from last week? Questions from the assignment that I believe was due yesterday. Hello, Polly. Everybody got it in, right? First 2B and 2A, is that right? Okay. Okay. So tomorrow, the Friday section is going to be an extended office hours. So if you have any questions, you want to get, you want to find out more, Gates 360, 3:30 to 5. Yes? Okay. Very soon, I believe next week, we're going to start having guest lecturers in from the industry. So I would encourage you to go check them out. They're always pretty interesting to see different perspectives. Last year, each one had a different specialty, whether it be OpenGL. Some people talked about how to get your apps on the App Store. There were ones focused on design. So we're going to try and give you a variety of different topics for each week. Can we get the Tweety guy? Well, yeah, maybe he left the country. He fled after the last lecture. We'll do our best. We have some good people in store, actually, some really cool people. So today's topics, once again, we're going to talk about how to really architect your iPhone application. We're going to get into some of the guts of Model View Controller and what we can do, some pieces that will help you build things that way, and in particular, view controllers, which we'll touch upon this week and show you how to use. And next week, we'll show you how to integrate into some more complex view systems. So let's get started. First, a little bit about the thinking behind designing an iPhone application. Here are two apps that you're probably familiar with. The one on the left here is Mail for the desktop on the Mac, and the one on the right is Mail for the iPhone. Both are very similar in terms of what they allow you to do. The capabilities are almost identical. But the view, the way that the applications display the data to you are very different. On the Mac, of course, you have a lot more real estate, and it takes advantage of that. So if you take a look at the Mac, the interface on the Mac, on the left side you have your mailboxes and folders. On the top of the main window you have the different messages in each mailbox. And below that in the main window you have the content per message for every message that's selected. Now on top of that, you can also double-click on a mail message and open it in another window. Now, that's great. It's great to be able to see all that information at once. But when you move over to the iPhone, we're talking about 320 by 480 pixels on the screen. It's pretty limited in terms of size and resolution. And while I don't want to, it's a different creature. It's certainly no less of an experience, but it's a very different experience. And on the iPhone, if you're familiar with Mail on that, it's a lot more hierarchical. So instead of trying to display the inbox and the mailboxes and the content on one screen, you dig into each, and on one screen you actually see one component of that. So in this case, we see the content. And down at the bottom, there's a toolbar for accessing things that are important to you. On the Mac, the toolbar tends to be at the top. And then, of course, the navigation bar, which we'll get into a little more. So how to organize your content? Well, you could go the route of putting everything on one screen, but there's really not much focus there. And there's so many controls that your user will probably not use at one time that it uses up a lot of real estate that could be used for other things. So the thing that, the philosophy we preach about presenting data on the iPhone is to maximize the space you spend showing people data. That's what people really care about. That's why they become attached to your application, is the way that you let them manipulate their data. So we contrast what we just had to Mail, and it's very focused on the message, the emails that come in, and the controls are pushed off to the top and the bottom. If we look at the Photos app, once again, it focuses very much on the user's data. In fact, so much so that the photos fill the screen. They go up beyond the navigation bar and beyond the toolbar at the bottom, and even into the status bar up at the top. So you maximize the space for the user's information. So Another thing about these screenfuls of data is that you're going to show one thing at a time. In the mail case, you show mailboxes. And when you click on a mailbox, then you show the messages in that mailbox. And you don't show any of the content until you click on a message. And then you go in and you can see more information. And again, you're going to hear me say this a lot today. We focus on screenfuls of content. So the idea is that your entire screen is filled up with one particular aspect of the data that you're trying to represent. So there are a few different patterns that have kind of become standard on the iPhone. One is a navigation bar, which you heard me talk about, and you've seen throughout the iPhone, including Mail, where you have a title that tells you what section you're in. You have the ability to navigate back to what you came from, typically, unless you're at a top level, in which case it may be some different kind of button. And then you may have another button in the navigation bar that's another kind of control, right? In this case, this is contacts. Your title is there, it tells you it's all contacts, and in the top right corner there's a button to add another add another contact. The second design pattern that you see frequently is the tab bar. And the tab bar down at the bottom shows different views of the same application. And if we think about the iPod app, in this case we'll talk a little more about clock in a moment, but if you think about the iPod app, each tab is a different category of the view. So it could be artists, albums, songs. There are different ways of looking at the same data. So let's talk a little bit about navigation bar a little more, where here we have a hierarchy of content. As you can see, you click on an item and it goes into another screen. And the navigation bar, let's do that again. The navigation bar, tab bar. Okay, watch the animation. So we're going to click on an item and it steps in two levels. When you click on the back button, it goes back. So there's three levels of screenfuls of data there. It's a drill down model. The other way to do this is the tab bar. The other way to represent data is the tab bar. And this one is mutually exclusive pieces of content. And clock illustrates it really well, where here there are different kinds of things. You have a world clock, you have an alarm clock, you have a stopwatch, but they're kind of like little mini apps within the greater clock app. So a screen full of content is really, it's a slice of your application. It's a category of data. And it's made up of a few different pieces. There's views, which are unique to each view controller. There's the data that you display. And then there's the logic. And the logic itself lives in your controller class, as we talk about model view controller. So here we go. On the last page, the Contacts app, we have a model, which is the contact database. And if you're interested, that's actually part of the iPhone OS. You can access that. In the view side, you have each of the cells for the users. And so each cell displays data that is relevant to that cell. And in between, you have the controller. Right? The controller is the one that mediates the data from the model to the view. And if the user goes and changes things, of course, they're interacting with the view. Well, the view tells the model, the view tells the controller, and the controller then modifies the model as appropriate. So in general, this is the communication mechanism. The controller talks to the model. The model feeds data to the controller. And the controller feeds data to the view, and the view manipulates the data through the controller. So everything goes through the controller. So a little more about model view controller. Well, why do you want it, and how do you build your application to support that? I'm sure you're all familiar with the term spaghetti code. Everybody knows spaghetti code, right? It's when there's so much code and everything's referencing everything else, and it's hard to untangle. One thing about model view controller is it lets you break things into smaller pieces. It gives you a way to conceptualize your architecture such that there's boundaries between each of these different pieces. So, and of course, we're trying to, by having different controllers, you avoid having one giant class that controls everything in your application. So you're avoiding this, the giant spaghetti monster. So why, what else? Why would you use model view controller? Well, it leads to reusability. So if you can build a controller class that is very focused on one aspect of your application, then you're able to reuse that again later. Similarly, for models and views, if you can build a view that knows nothing about the model that it's representing, then that view can then go on and be used in different ways. And the model, well, if you think about your polygon class that you've created so far, you can take that polygon class, if it's designed right, that it doesn't know anything about the controller or the view above it, you can take that polygon class to a different computer and build a different application on top of it that represents the data in a different way. So, reusability, another advantage of reusability is that it helps you write less code. Right? If you build things in a generic way and you can reuse them, you don't have to rewrite them or copy and paste later. Yes?
Could you take the analogy of object-oriented? So the model is the class, and the controller is the kind of a singleton?
So the question is, in object-oriented programming, is the model the class and the controller the singleton? And no, not necessarily. The model represents your data, right? So you can have classes for data, you can have classes for controllers, and we'll talk about reusing those controllers in a little bit. And even, of course, views are different classes as well. So they're really different kinds of classes. There's classes that represent the information itself. There's classes that manage the workflow, and there are classes that represent things on screen. And that's the boundaries, model view controller. Any other questions? No. Okay. So how do these objects talk to each other? Right? If they're supposed to be so separate from each other, how do they communicate? Well, let's start with the model. So in the example that we've already done in the assignment, the polygon class, it doesn't know anything about the views that represent it, and in fact, it doesn't even know about the controller that's manipulating the data. And it's completely reusable. You take that polygon class, like I said, you can put it on another system, build something else on top of it. So how does it communicate? Well, there are two ways in Cocoa that are pretty useful, very, very useful. One is KVO, or key value observing. And that's a mechanism by which one object can listen to changes on another object. So in our polygon class, let's say your polygon class has an IVAR called number of sides. Your controller class can add itself as an observer to the model class and say, I want to listen for changes to number of sides. And we won't get into the details of that. We do talk about that in a few lectures. But that's one way that the model, who knows nothing about the people above it, can broadcast information. Another way is something a lot more general, which is something called notifications. And there's a singleton class in each application called NS Notification Center, which allows broadcast of messages. And let's just say messages are strings. So if your polygon, for some reason, it changes sides, it changes number of sides, it could create a message called my message change number of sides. It would post that notification. The notification center hears it, it gets that message, and then broadcasts. And anybody who's listened for the my message number of sides have changed will receive that message and can do what they need to do at that time. So I think we'll talk about notifications again later in the term as well. But those are two different mechanisms by which the model can broadcast changes about itself. The KVO stuff you mostly get for free. You get for free in a lot of cases. You have the ability to override, which is why I say mostly. But if you use properties, or if you use proper setters and getters, when you say, polygon class dot number of sides equals 3, then that will automatically fire off messages to any observers on it. So pretty cool. Now, how does a view communicate? Well, it's not aware of the controllers either, right? But it is able to send messages through target action, which we've talked about, right? So a controller object can set itself as the target for specific actions on a view object. And another way is through delegation, which we talked about a bit a couple weeks ago, last week maybe. But again, we're not going to get into detail until we start talking about table views in a couple weeks, I believe next Thursday. And delegation is a way for one object to broadcast certain types of messages that, or call methods on a delegate object. So those are two ways that the view can talk to people that are listening for. So now the controller. Well, the controller is the one that does all the dirty work. He knows about what model and view control, what models and views it cares about, and it's the brains of the operation. So it does all of the management in between. It's typically app-specific, so when we talk about reusability, we're not, in this case, for views and models, I encourage you to think reusability across applications. But when we talk about reusability for controllers, it's less about, it's pretty rare that you're going to take controllers that you build and use them in other applications. But it could still be reusable within your application. And as you build your paparazzi app later in the term, you'll see this pretty useful. So again, we have our model view controller. You get pretty used to this kind of diagram. We show it a lot. The controller has outlets to the model. So it has I-bars that point to the model that it's trying to represent. And it has an outlet to the view in case it needs to manipulate the view. And then each one, the model and the view, both can communicate with the controller through the mechanisms that we just discussed. So any questions about that kind of greater philosophy, the design pattern about model and view controller? Everybody getting it? Everybody understand? Okay. Well, this is where we start talking about a standard class view controllers that allow you to do some things a lot more easily, specifically how to manage screenfuls of data in an easy way on the iPhone. So the view controller, of course, it knows about its views and it knows about the data that it's trying to represent, but it's really the center of logic for each of these screenfuls. You'll have several of these in your app. If you have a navigation bar, if you have a navigation type application, generally each one of the screens that go by is another view controller. It doesn't have to be. In fact, you could go in and animate the navigation controller yourself. You can tell your views to animate. You can change the navigation bar. But if you build things with view controllers, you get a lot of stuff for free. So what the view controllers are, they really, it's a class that gives you a big starting point. Just like UI view, which we talked about last week, is a great starting point for representing views on screen. View controller is the same thing for having a standard way of representing controllers. Again, a few different flows that you may want to consider, which use view controllers fairly heavily. Navigation. So when you step into a screenful, that's generally another view controller. Tab bars. So if you think about the clock. Right, there are 4 different tabs, so there are 4 different view controllers. One is the world clock, one is the alarms, and none of them know anything about each other, but they're each kind of neighbors that live side by side that you can switch between. Or you can combine the two, and I'm sure you've seen apps that have both navigation bars and tab bars. And I think on Tuesday we'll talk about how to do that, what the proper design pattern is for that. So, we encourage you use these things because you get around having to reinvent the wheel for a lot of messages you'll want from your application to be able to display these things. So again, view controller is the basic building block for your navigation and your flow. It manages one view at a time, and what you do is you tend to subclass it. So there's a generic UI view controller which you'll use as a subclass for your view controllers. There are some specific ones that you may not need to subclass. Navigation controller and tab bar controller you generally don't subclass. But other ones like table view controller, where you need some specific information to be pushed up to your view controller, you'll subclass that. So your view controller contains the views data and the logic. And it's the glue that ties the two together, right? So you think about it as the views and the data over here. The controller is the one that ties the two together, sends the messages between them. So when you create another view controller for yourself for a specific part of your application, you're going to subclass UI view controller. And you're going to take them and you're going to plug them together in different ways. Again, we've talked about tab bar, and we've talked about navigation controller. You may have your own method of going between them, so you may come up with your own design pattern. You may just want, when you tap on a button, you may want to flip the screen. Each one of those would be a different view controller. So in this case, navigation, we have 3 different view controllers, and that's your stack, right? That's your hierarchy in the view controller, in the navigation controller. And the navigation controller lets you go into and out of each of these. Similarly, in the tab bar controller, you have different view controllers that are neighbors with each other, and each one lives side by side. So now, how do you implement a UI view controller subclass? Well, here's the header. So you start with, of course, you import UIKit. You subclass off of UI view controller, and you should all know about subclassing by now. And then you'll have pointers to your data and pointers to your label. Now, this may have an IB outlet in front of the label if you're using a nib. I'll show you how to build view controllers with and without nibs. And then you'll have, so here's properties. You'll have some property in case anybody needs to communicate with your view controller to get data or set it. And it may have actions as well, right? So if items on your view are able to do something to your controller, of course, and that would say IB action, then that's what your view would call into. Now, how do you set up a view in a view controller? Well, there are 2 different ways. Well, a couple things to note first is when you create a view controller, it doesn't automatically create the view. The view is only created when you need it. And the reason we do that is you may have several different views in your application, several different screenfuls that you want to represent. But they don't all necessarily have to be, only one of them is going to be on screen at a time. So there's no sense in going and allocating. This is probably the most expensive part of your app, which are the views. No sense in going and allocating all those things until you need them. Another thing that the app will do for you, we've already seen the UI application has a way of telling you when your application is running low on memory. So the view controllers will make things even easier for you by purging memory automatically. And they'll tell you when they're going to purge memory, so you can go ahead and get rid of more things than they would have otherwise gotten rid of. But by default, they'll dump the view when memory is low. And then you can recreate it when you need it again. Another thing it does very well is sizing and positioning. So when you want to do rotation on the screen, it helps with that. And it will help you make sure that your screens are not specifically built for one size. So if we take the iPhone, right, it has a 320 by 480 screen, and when you put a view, if you get it to fill the screen, you have a status bar up at the top, and it's going to be 320 by 460. If you put that same view controller in a navigation bar, well, you lost 44 pixels. And if you put that same view controller in a tab bar, you lost another 49 pixels or whatever it is. So your view controller has to be flexible in terms of size. You can even, you can go from one view controller to the next and have the second view controller push away the tab bar and even the status bar and get more screen real estate. But the point being that the view controller should be able to reposition the views as necessary based on the screen that it's representing. So 2 ways to get your view to load, right? One is you build stuff in a nib, and we'll show you that after. But the other way is by implementing in UI view controller a method called load view. Okay? And when load view gets called, that's your signal to go ahead and start building the subviews that you want to represent in your view. So you don't ever want to call load view. This is another one of those cases, you've heard this 4 or 5 times by now, that you don't want to call this yourself, right? You let the view controller, you let the application call load view on your view controller when it feels it's appropriate. And that's when it's going to display that view. Again, you've heard this a lot. We tell you don't ever call dealloc yourself. In the view case, instead of calling load view yourself or even draw rect, you tell the view set needs display. And the application the drawing tree will go ahead and draw that the next time it needs to. This is an advantage for the OS. It's an advantage for your application. Helps with performance. So let's look at load view. When you're going to create your own view controllers, this is how you would go ahead and actually build subviews in code. You implement load view, and in there you will go ahead and allocate whatever subview you want to put in. You're going to release it, of course, because you're good about memory. And you're going to assign it to be the view of your view controller. By assigning whatever view you create in here as your view controller, now your view controller has a view. That view is an instance variable of the superclass. Whenever the application wants to display that view controller, it will always call, your view controller.view, which may or may not cause it to load, and that's what it's going to move around. You create a view controller with init. There's also an init with nib name. It's init with nib name : bundle : So how do you create your view in Interface Builder? How do you create your view controller in Interface Builder? Well, you lay it out the way we've laid out Interface Builder already. You set up, by default, your view controller when you create it is going to say init with nib name. And the nib name is going to be whatever nib that you've specified. So if you name it, my view controller, your nib name is my view controller. You leave off the .xib at the end. And what happens is when that loads, it becomes the file's owner, which you've seen in your nib so far. Right? It's something we've told you don't worry about. But what happens is when you load a nib, an object has to be the owner for that nib. That's how it gets the references that are assigned to it. Well, in this case, the view controller, the view controller becomes the file's owner for that nib. So you hook up any outlets from the nib, from the view controller, from the file's owner to the view, and that's how you create it, init with nib name. So now, let me show you how to do this with Interface Builder. All right, let's close this. Let's close this. Let's go back to Xcode. And this is where the templates become really useful. So I create a new project. I say view-based application. And let's call it my VC nib app. All right. So when we look inside of this, there are a few different resources, right? There's the main window.xib, which is our main nib for the app. And there's a second view controller nib, which is my VC nib. It's already named based on what we told the app to be named. And it's created an app delegate, just like it did with the window-based application. And it creates another class, which is the app view controller, my nib, my VC nib app view controller. Now, if we look at the .h, we'll see it's a subclass of UI view controller. And inside here, there are several functions that it's already kind of templated for us and commented out, but are there in case we want to use them. And you'll notice here, one of them is the designated initializer, which is init with nib name or nil, and bundle. So if we look at our main window, we've already seen this. It's already put a view controller in the main window nib, which will cause an instance to get instantiated for us. And what it's done, this is, again, all happening in Interface Builder. Let's see. If I do a get info on that view controller, I believe it's already named the nib for us. So you can specify a view controller in one nib, tell it what the nib name is, and that will get loaded for you automatically. So now let's look at the implementation. Well, we have, it's already created this viewDidUnload method. So there's two different flavors of loading views that are important. One is when you do it by hand, right? It's going to call load view for you, and it's going to expect you to assign a newly created view to the self.view, to the view IVAR for your view controller. But if you do this in the nib, you do this using viewDidLoad. That's right here. So what happens is the nib actually brings the view in for you. It creates it for you. But what viewDidLoad does is it gives you an opportunity to customize it. So let's go do an example where we're going to customize here. So let's open up the view controller's nib. Kind of a crowded screen here. Let's close the window. All right, so this is our view controller's nib. You'll notice that if I click on the files owner and I do a get info on that, you'll see the class of that files owner is my VCNib app view controller. Now, when I go ahead and double click on the view, let's put something in there like well, let's put a label. Where is it? If I go to the library and I take a label and I drag it in, let's resize it. Right. So we'll go back to Xcode and we'll just run this. Now we didn't do anything in viewDidLoad, but because that view, and I'll show you the nib in a second, because that view is assigned in the nib, it gets loaded for us automatically. So let me show you really quickly in the nib. If I go to the files owner and then I look at the relationships, which is the second tab, you'll see that the view is already assigned, and it's actually this one right here. So it's already assigned. Now, what you're familiar with already, I think, is how to set up outlets. So let's go. I'll show you how to customize here. So we're going to say IB outlet UI label. Let's do this. In our load view, viewDidLoad, let's set the text label. Label.text equals, this better work. All right. Now we need to make sure that we assign the outlet. So let's open this up. Of course, this is the hierarchical view of our nib. If I control drag from the files owner to the label, we assign it to label. It gives us the choice of assigning view. But of course, if we assign view, the label would actually be the greater view that we're moving around. So we want it to be we're just going to assign it to label. Now I hit run. This better work. It did. Sweet. Okay. Now I'll talk a little bit in a few minutes about when to get other messages, what other messages you might want to get from your view controller. So a little bit about the life cycle of these things. Well, when do they get loaded, initialized? When do other methods get called on it for your view? So first, this is the designated initializer for your nib. Right? Init with nib name. Now what this does is it allows you to create a view. I don't want to get too much into this, but you can create a view controller that has different nibs, right? So like if you want, let's say, 2 visual representations or subsets of the same data, let's not worry about that too much. But you pass in the nib name as a string, and that will bring it in. In your initialization, that's when you might want to create data or fetch data, and you can set the title for your view controller. Where the title comes in handy is, let's say you put that view controller in a navigation bar or even in a tab bar controller. Those titles get set for you automatically. So as you push and pop these view controllers, the title will change to whatever the view controller's title is. Once again, viewDidLoad. So if you're building your view controller from a nib, once the nib is loaded, viewDidLoad will call, and you have a chance there to customize for size or any other customization you want to do on the view. There are 4 methods that we care about for knowing when the views come and go. Right? The first is view will appear. So if we take the navigation controller example, we take the navigation controller as an example. Your view controller will get pushed. Right? It's animated in. So there are 2 methods that get called. The first is view will appear, which happens before the view comes on screen, but right before it's about to show up. And this is where you may want to start loading expensive data, right? So if you have to go fetch something from the web, that's when you know that your view controller is actually going to get displayed. So it's time to go update. Then there's the view will disappear. So right before your view is about to go off screen, you have a chance to do whatever you need to do, save your data because it's about to go away. I don't remember if these are in there. There's two others that are really interesting here. There is so I said there's a view will appear. There it is. A view will appear happens before your navigation controller shows the object, but once your view controller has come completely into display and has stopped animating, you'll get a view did appear. And one way that view did appear might be useful is, let's say you have a table view, okay, that displays a bunch of content, and you stepped into another view controller, which means the user selected one of the items. When that navigation controller pops, when it goes back, you want to wait until it's done animating and then animate the deselection of the cell, right? So you see that a lot even in mail. You click on something, it goes in. When the user hits the back button, it comes out, the cell is still selected, and then it fades away. So that's a view did appear. And then there's also a view did disappear to tell you it's completely off screen. And again, the animated parameter here will tell you if it's actually being animated on or off, or if it's just going away. So I want to talk about loading and saving data, right? So I just showed you view will appear and view will disappear. Those are great opportunities to go and fetch data that you want to display, and great opportunities to save them as well. So for simplicity, I'll show you this with a user default, with preferences, which I think you've all used by now with the Hello Poly assignment. Let's do this. So if we remember this little thing that we just ran, when I run, it's going to, it just shows the same piece of data. Let's do something a little more sophisticated here. Let's go into our nib, and let's change this to be a text field. Or let's change this to be a slider. Okay, or put one right below. Okay, so we now have in our view a slider. It's going to go all the way across the screen. And let's make it go from 0 to 100. So if I look at our inspector, we have a minimum of 0, we have a maximum of 100. What I'm going to do is I'm going to save the value every time you quit the app. And then when you reload, we're just going to restore that value. So view did load. I think we're clear. We're clear. So let's override view will appear and view will disappear. We're going to say view will appear, bool animated. And we're going to say view will disappear. And that takes the animated parameter. So in view will, let's look at view will disappear first. Let's put an outlet to our slider, IB outlet, UI slider, slider. And let's hook those up. So here's our controller. We're going to control drag from the files owner. We'll just go in this hierarchy here to the slider there, and we'll set that up. And now, what we're going to do is go back to Xcode, and when the view is about to disappear, let's save the value. So we'll get a floating point value, which is the slider value equals slider.value. And we'll save that to prefs. So NS user defaults, standard user defaults, and let's do set float slider value for key slider value, right? pretty obvious. Now in view will appear, let's load that. So right before the view is about to come on screen, we're going to ns user defaults, standard user defaults, float for key, slider value, float slider value. And now let's assign it. So slider.value equals slider value. And that should show back up. We can update the text if we want to. Let's just do that really quick. Label.text equals ns string with format %f slider value. All right. This is not going to update as you change the slider. It's only going to update when you load up the next time. So I'm going to just move this guy around, and I'm going to leave it there. And when I quit and I relaunch the app, let's run it from there again. It has taken the value from pref, set the slider back up the way it's supposed to be, and then it shows us the value as well. Yeah?
What happened the first time you loaded the app? Like, loading the value from the default to something that you had.
Right, so the question is, what happened the first time I ran the app? So the second time, right, it loads because we saved the value. The first time I loaded, there was no slider value assigned in defaults. So let's take a look at this. When I say float for key, slider value, what comes back is nil, right? And we already know that, we tend to fail gracefully in Cocoa across all of the APIs. Well, in this case, when this fails, it's going to return 0. And so we take the 0 value, we assign it to the slider, it's over on the left side, and we assign it to the text. Now, if you want to check to see if that value is there are methods to do that on standard defaults. You could say, there may be I don't know if it's, I don't remember what it's called, but on standard, if you look at the headers for standard defaults, there's a way to see which keys are there. What's that? Any questions? Okay. All right, back to our keynote. That's loading and saving data. You'll also get a bunch of other hooks for free with View Controller, right? So one of them, as I talked about, is memory warnings. So when the app is running low, your View Controller can override a method called I don't know, something about running out of memory. We can look at the headers. And then it'll also help you set up orientation. So this is something that's a little sexier than memory warnings. Your View Controller can override methods to tell it what orientations your View Controller is able to display things in. And then you'll also get messages when your View Controller is about to rotate, so that you know if you need to do things. And you see some apps will reposition data. Hopefully they at least grow things properly, but in more sophisticated apps, they'll maybe even change the views a little bit. You may see something different in portrait than you do in landscape. So to support interface rotation, you do all of this in your View Controller. So you override a method called should auto-rotate to interface orientation. And it passes one in to ask you, can you rotate to portrait, portrait upside down, landscape right, and landscape left? In this example here, we're only going to return yes for supports portrait, which means if the user rotates their phone, it's not going to do anything. The things are going to stay the way they were. If we change that to yes for landscape left, for example, when the user rotated to the right, it would be in landscape left, and your View Controller would rotate, and you would do the resizing. So here's a case where we actually support everything except upside down, right? So for landscape orientations, landscape left, landscape right, portrait, and portrait upside down, we're going to return no, we don't support interface orientation, don't rotate in the upside down case, and yes for every other case. So let's do that really quick. So let's see. Conveniently, this is already in the template, and it's set up to only return yes for portrait. So let's just return yes for all. And let's see what that does. Okay, so if I go to the menu here, and I say rotate left, which is command left and right, so let's do rotate left, you see my view controller rotated pretty easily. And we should be able to go all the way around. So it always stays up, right? It doesn't matter which way we go. Now you'll notice all it's doing right now is it's taking the positioning of the elements that are already in there and shifting them down. So our slider is no longer near the middle of the page, it's somewhere near the bottom. It's no longer the width of the page, it's somewhere near the bottom. Well, this is where you might want to go into Interface Builder and set up something called struts and springs. So when your view controller says, yes, I auto-rotate, its view is going to be told, this is your new size. But if your subviews aren't ready to reposition themselves, then they'll just stay where they are. So let's look at the nib, and let's look at a couple of things in the inspector here. So our label, let's just to make this really clear, let's take our label and let's make it align center. And then let's go to this third tab of the inspector. And this is our auto-sizing control. So we can tell the label that it should resize. If there's stuff outside the square and there's stuff inside the square. And if you take a look at the animation, you can kind of see what it's supposed to do. But I'm going to tell it to resize in the horizontal direction, but to keep its left, top, and right margins fixed. But it's going to allow the bottom margin to change. So if you look at the animation, that means it stays near the top when your view changes size. Let's take our slider, and actually let's put it at the bottom. So we're going to say that yes, it's allowed to change sizes horizontally, but it keeps its left, right, and bottom margins the same. And now I just save that, and what should happen is, when I hit run, these things should automatically reposition themselves. So when I rotate, they stay in the center, one to the top, one to the bottom, and they've grown to fit the sizes that are appropriate. So all the way around. All right, I think we're near the end here. So auto resizing your views, I just showed you this. I showed you how to do it in the nib. You can also do it in code. Sometimes it's convenient to do it in code if you're building your views in code. You set the auto resizing mask on your UI view, and all UI views support this. Flexible width and flexible height are essentially the same as turning on the springs in the middle, both directions on that view that I just showed you. So that's this case. Flexible width and flexible top margin is similar, but by saying that the top margin is flexible means to turn off the top strut over here. So that's it. That's all I have. Let's look at the memory warning thing really quick. So this one's really important to you, and we'll get into memory management a little later in the term, but there's a method that I believe is already in the template called, that's not in the template, something like, oh, it's right there. So here, in your view controller, there's a did receive memory warning. The reason it's in the template for you is because it's important, right? By overriding this gives you a chance to get rid of anything you're holding on to that you don't want to keep. So, like I said, if your view is not on screen, the OS will dump the view for you. If your view controller is not on screen, the OS will dump your view. And then the next time it wants to display it, it's going to call load view or view did load, whichever is appropriate for your view controller. But here's the chance to dump any data, right? So the view is going to get dumped for you. This is the chance to get rid of any photos or images or stuff like that that's cached for you. So yeah. What else? Anything interesting in this template? Yeah, that's basically it. Any questions about view controllers? So again, once we get to the next project, it's going to be very heavily based on view controllers. You will have a navigation controller. I believe there's a tab bar controller as well. So all these pieces will be necessary. That's it.
For more, please visit us at stanford.edu.